At this point, you've heard Mike talk about all of the perils related to malware infections. Well, let's take that just a little bit further. What we're really talking about is endpoint detection and response, otherwise called EDR. What's an endpoint? An endpoint is usually a user device, but it could also be a firewall on the network's edge. It's any device where we want to have some kind of detection of suspicious activity, including malware. So the idea is we want to have alarms that get triggered. For example, on a user device, whether it's a smartphone or a laptop, if there's a malware infection, we want the user to know about it. Pop it up right in front of their face with a notification. Now, in the enterprise, this is where buying enterprise malware solutions make sense and are worthwhile because we can have that centralized. If there's a malware incident on an individual device and we manage 2,000 devices, it would be nice if it popped up in a central console, maybe notified administrators through a text message or an email. So in the enterprise, it makes sense then to look at solutions that do that. We can also have a host-based firewall. Now, this is again all part of endpoint protection, having a firewall to limit traffic coming in, but having a virus scanner is yet totally different. Because if a user's opening malware as a file attachment in an email message, it's already inside the firewall. So we need both, not one or the other. We need host-based firewalls and we need anti-malware. So let's take a look at what we might see in a standard Windows Server environment with the built-in Windows Defender anti-malware solution. So here in Windows, I'm going to go ahead and fire up a web browser because what I want to do is navigate to a website out on the internet that will allow me to get into actual live malware. Now, make sure you do not do this on a real machine on a production network. If you start playing around with live malware sites, depending on how your machine is configured or not configured, you can infect your machine or your entire network. So this isn't for the faint at heart. We're just looking at this to illustrate how some of these things work with endpoint detection and response. So, for example, let's say I want to go down here and download some kind of malware. Now remember Stuxnet? We talked about Stuxnet being a worm that was used essentially to report false information to monitoring stations in an Iranian nuclear plant for uranium enrichment. So we actually have a copy of that malware here. So if I go ahead and click on that link for Stuxnet, and if I click to download the zip file, and I'll click View Raw, so at this point, I can choose to save that file. But what happened is Windows Defender picked it up. It says that it's a virus, and it was deleted. That's good. We want that to happen. However, that's only because real-time protection is turned on, which it is by default. So I'm going to go into my Start menu, type in Defend, and I'm going to go into Windows Defender Settings. Now, what would happen, I wonder, if I tried to do the same thing, but real-time protection is off? I think you can guess. It would allow you to download it. But let's just verify that that's the case. So back where we were downloading that, I'll click View Raw again, where it'll prompt me to download that item. And I'll choose, let's say, Save As. We'll put that in our local downloads folder. And it did it. So this is illustrating the absolute relevance of real-time virus monitoring. Otherwise, things can slip through the cracks. Now, the thing that's scary too is sometimes administrators will temporarily disable the virus scanner because otherwise they can't install a certain piece of software. I've done it myself. The problem is when you forget to turn it back on. So that does happen. So we want to watch out for that type of thing. Now, let's go explore what we've just downloaded. So I'm going to go to my downloads folder. There's the zip file. And if I actually right-click on that and choose Extract All, I'll just accept the defaults to basically unzip it. There's a little executable file that is the Stuxnet worm. Now, Stuxnet looked for certain types of PLC or programmable logic controller industrial equipment. So that one I know is not going to harm anything here, but I'm not going to run it anyways. But the point is, it was caught by Windows Defender when real-time protection was on. Now, as if that wasn't fun enough already, let's do some more. Let's go back to, I'm going to go on the breadcrumb trail here, back to malwares with an S, and I'm going to click Source. So we've all heard about ransomware. The most common forms of ransomware will infect your machine and they will encrypt data files and demand some kind of a ransom payment, usually through an anonymous mechanism like Bitcoin. Anyway, let's go to Source here And maybe what we'll do, I'm going to go to the original folder. And next thing we want to do is pick anything we can choose here to look at would be fine, but I want to go into the Jigsaw ransomware. Now in here, I'm going to download the zip file for Jigsaw. I'll click View Raw to download it, save it in my Downloads folder. And that happened, no problem. So I'm going to go ahead and unzip the ransomware source files. So this isn't the executable, it's actually the source code, the programming language code. So let's go ahead and extract it real quick. The only reason I want to do this is because there's a lot to be learned by looking at this if you find malware analysis interesting. For example, if I go into the config.cs program file, here I see some actual code that is executing, including comments left by the author of the code. That would be the malicious user that built this malicious payload. And as we go through, we'll even see exactly what it's doing, such as the fact that it actually has the encryption password hard-coded. Now, that's poor programming practice for the malicious user. They should know better than to store the encryption password here, because we can easily reverse engineer this and we can get the decryption key, perhaps, without paying a ransom. But at any rate, we are looking at the actual code, the source code, that makes this work. And usually the source code is written often in the C programming language. Doesn't have to be, but often that's the case. So besides virus scanners and host-based firewalls, we should also think about intrusion detection systems. A host intrusion detection system runs on a host and looks for suspicious activity. You might say, what do you mean suspicious activity? Well, that's the point. You have to tweak it for your environment to detect what is not considered to be normal. So a host intrusion detection system could look at log files, it can look at traffic coming into or leaving an individual device, and when it detects something suspicious, it can write to a log or send some kind of notification to an administrator. Now, host intrusion prevention is a little bit different. It takes it a step further because it can also take steps to actively block or stop the current suspicious activity, maybe by blocking an IP address. Then we have next-generation firewalls, NGFWs. This combines a lot of security features into one piece of software or one hardware appliance, such as packet filtering for OSI Layer 4. That's standard packet filtering to allow or deny traffic based on IP addresses and port numbers and protocol types. But it can also support deep packet inspection at OSI Layer 7, which means besides just examining packet headers, it can look at the payload in the packet to decide whether or not that traffic should be allowed. So intrusion detection and prevention then is also something that you'll find built in to next-generation firewall solutions. When you configure firewalls, when you configure next-generation firewalls or intrusion detection systems, depending on the solution, you might also be able to create an allow list, which is sometimes also called a whitelist. This means what type of activity is allowed, what apps are allowed to run on stations, what traffic is allowed through the firewall, what type of apps are allowed to make changes to sensitive places on a machine like the Windows registry. The opposite of an allow list would be a block or a deny list, often called a blacklist. This means things that are not allowed to run, like apps, or traffic that is not allowed to enter or leave a network. So we've seen then that there are multiple things that we can do to secure our endpoints, from virus scanning to intrusion detection to next-generation firewalls.